Hello everyone, welcome back. This is the fourth video in Prime Time series. So today we have already done the prime numbers. So today we will visit the co-prime numbers. We will see what are co-prime numbers. Co-prime numbers are numbers. Two numbers are said to be co-prime to each other if they have no common factor other than 1. So they may be prime or not prime, doesn't matter. What matters is that there should not be any common factor between them other than 1, because 1 is a factor of every number. So other than 1, any other number cannot be a factor of these numbers. So let us see a few examples. As 15 and 39, both of them have common factor as 3. So they are not co-prime. What about 4 and 9? 4 and 9, they are not primes, but they do not have any common factor other than 1, so they are said to be co-prime numbers. So co-prime number properties. Let us see what are the properties of co-prime numbers. So sometimes the first common multiple of two numbers is same as the product of the two numbers. For example, 4 and 9, they are co-prime numbers. So their first common multiple is 36. At other times, the first common multiple is less than the product of the two numbers. For example, 4 and 6. 4 and 6, the first common multiple is 12. And it is not 24, which is less than the product of the numbers. So first common multiple is less than the product of the two numbers. How is it related to the number pair being co-prime? So if they are co-prime, then the first one is true. Green one, sometimes the first common multiple is same as the product of the two numbers. This is true if the two numbers are co-prime. And the second part is true if the numbers are not co-prime. That means they have a common factor other than 1. So this is some art using co-prime numbers. So actually there is a circle and around it we are marking numbers. Each one we are marking numbers, and then we are tying a thread at the largest number. So first circle, if you see, the largest number is 12. So we tie the thread, we start the thread from the number 12. Then we leave a gap of 4. And we start tying the thread from 12 to 4, 4 to 8, 8 to 12 back again. So this way, if we see the number, the largest number, that is 12, and the gap, that is 4. So they have some common factor. They are not co-prime, 12 and 4. So in that case, we will get such a like figure where all the pegs are not touched. All the numbers are not touched. If you see the second figure, 13 and the gap is 3. Both are prime numbers. So they will be obviously co-prime numbers. So 13 and 3, they are co-prime numbers. So the thread will pass through all the lines, all the numbers, all the dots marked on the circle. So the next figure, if you see, the largest number is 16 and the gap is 6. So they have a common factor 2. So if you see that this figure that has some gaps, so some numbers are skipped. In the next figure also, many numbers are skipped because 24 and 6, the common factor, there are a lot of common factors between 24 and 6 other than 1. So this is, in some diagrams, the thread is tied to every peg. In some, it is not. Is it related to the two numbers being co-prime? The number of pegs and the thread gap. These, if they are co-prime, then the thread will pass through all the pegs, all the numbers. If they are not co-prime, then there will be some gaps. Next, we come to the prime factorization. Keep breaking the composite numbers into factors till only primes are left. For any number, it is a remarkable fact that there is only one prime factorization, except that the prime factors may come in different orders. The order is not important. Break 30, then you get 2 into 3 into 5. Now you can put it in any order, doesn't matter. But the final product will be same. If you do 2 into 3 into 5, that is same as 5 into 2 into 3 or 3 into 5 into 2. The order doesn't matter, right? So whenever we do a prime factorization of any number, it will be unique if you don't consider the order. Let us do some figure it outs from the textbook Ganita Prakash. So the first question is, find the prime factorization of the following numbers. So let us see quickly each one. 64 is 2 multiplied 6 times. So 2 into 2 into 2 into 2 into 2. 104 is, this is a prime factorization. We cannot break it further. All these are prime factors. 105 is 3 into 5 into 7. 343 is again 3 to the power 5. That means 3 multiplied 5 times. 320 is 32 into 10. So 32 is 5 times 2. So 5 times 2 into 2 into 5. That is 10. 141 is 3 into 47. 47 is a prime number. So we cannot break it further. 1728 is 12 cube. So 12 cube, 2 into 3. If we do 3 times, again we multiply it 3 times, we'll get this factor. 729 is 3 to the power 6. So 3 appears 6 times in this product. 1024 is 2 multiplied 10 times. So 2 to the power 10. So the number of 2 will be 10. So it is dot dot we have given here. But there will be 10 2's. 1331 is 11 cube. So 11 multiplied 3 times. And 1000 is 10 to the power 2, but 10 is basically made up of 2 factors, 2 into 5. So 2 into 5 will repeat 3 times. So that is 2 into 2 into 2 and 5 into 5 into 5. So this is the prime factorization. So prime factorization means we cannot break it further. So this is the last stage of the factorization. Next problem is, prime factorization of a number has 1 2, 2 3's and 1 11. What is the number? So we know that there is a unique prime factorization for every number. So the number is, if we multiply 2, 1 2, 2 3 and 1 11, we get 198. So the next question is, find 3 prime numbers all less than 30 whose product is 1955. So we know that one factor has to be 5 because the last digit is 5. So one of the prime numbers is 5. So let us divide 1955 by 5. So we get 391. So now we can examine all the prime numbers less than 30. We can apply the trick that which two numbers can give the last digit as 1. And we find the numbers as 17 and 23. So all the numbers are 5, 17 and 23. If we multiply these 3 numbers, we get 1955. 1955. So these are the numbers. So the next problem is, find the prime factorization of these numbers without multiplying first. So we know that each number has a unique prime factorization. We don't need to multiply. So 56 we'll separately find out the prime factors. 25 also we can separately find the prime factors. So 56 is 8 sevens. So 8 is again made up of 3 2's, 2 3's, 2. If we multiply 2 3 times, then we get 8. So 2 into 2 into 2 into 7 is 56. And 25 is 5 squared. That is 5 into 5. Similarly, we do for the other numbers also. 108, we find the prime factorization, and 75 also we find the prime factorization. 1081. 81 is 3 to the power 4, so 4 threes. And 1000 is, we know that 10 to the power 3. So 10 is not a prime number. So we again further divide 10 as 2 into 5. That we might repeat 3 times. These are the prime factorizations. What is the smallest prime number whose prime factorization has 3 different prime numbers and B 4 different prime numbers? So the first one answer is small. First, we'll start all the prime numbers from the ascending order. We know that 2, 3, 5 are prime numbers. So we take the first 3 prime numbers and to get the number 30. Similarly, 4 different prime numbers. What is the next largest prime number? That is 7. So 30 into 7, we get the number 210. That's all for this video. Please like, subscribe, and share and comment if you have liked the video. Thank you.